and efficiencies associated with the Rankine cycle. So here's the process that you've seen in the class. Here you have a high pressurized stream of liquid water entering the boiler. Heat energy is supplied from burning of coal and fossil fuels, vaporizing the liquid stream into the vapor. Note that the enthalpy increases and the entropy increases. This superheated stream of vapor then enters the turbine. In the process, it produces work, and therefore our enthalpy decreases. But note that our entropy remains the same, 7 here and 7 here. So this process is isentropic. The stream exiting the turbine is mostly vapor, partially a small fraction of it is liquid. It enters the condenser, condensing into liquid water. The liquid water is then pressurized by the pump before it enters the boiler. So the question you're going to ask is, what is the efficiency of this process? So efficiency is simply net work divided by heat supplied. So the work in this example is work turbine minus work pump. So the work that's produced by the turbine minus the work that's consumed by the pump. And I'm going to put absolute symbols by both these terms in case they're negative. The heat supplied in this case is QH. So I'm going to determine all the three of these terms in the previous cycle. Okay, so let's start with the work turbine. Work turbine is equal to H3 minus H1. H3 in this case is 2800 minus 4000. This is negative 1200 kilojoules per kilogram. Okay, what is my work pump? That is H1 minus H4. One is 1000 minus 900. That is 100 kilojoules per kilogram. Okay. Okay, what is my QH? QH is equal to H2 minus H1. H2 is 4000 minus 1000. This is 3000 kilojoules per kilogram. Okay, so these are the three terms we needed to compute efficiencies. Our work done by the turbine is 1200. It's negative because it's work done by the system. Work done by the pump is positive 100. That's work done onto the system. And then our QH is the heat supply to the boiler. It's 3000 kilojoules per kilogram. So this is 1200 minus 100 divided by heat supplied, which is 3000. So if I compute this number, answer is 36.7%. Okay. So now my question is, what is the efficiency of, so this was assuming that our turbine produces reversible work. In reality, that won't be the case. So what if my turbine was 80% efficient? What that means is that work done by the turbine, the actual work done by the turbine is equal to 80% of the work done by the reversible turbine. So our actual work is 0.8. If I go back times 1200 that I computed previously, then the terms here, that's is equal to 960 kilojoules per kilogram. So my actual work done is less than the work done by a reversible process, which makes sense. So what is the overall efficiency of the process? So again, the efficiency is the same. Efficiency is simply work done by the turbine minus work done by the pump over heat supplied, which is QH. So here, work turbine, we already determined from the previous slide, is 960 kilojoules per kilogram. So that's already done. So our QH is the same, equals to 4,000 minus 1,000 is equal to 3,000 kilojoules per kilogram. Okay, so our actual work is 960. What that means is work turbine, again this is negative, so just put a negative sign there, is equal to H3 minus H2 is equal to 960. Note that our enthalpy of the entering stream remains the same, the pressure remains the same, so our entering conditions don't change. But since our turbine is not as efficient, our exiting conditions will change. So our enthalpy will no longer be 2800. In fact, our enthalpy here, H3, is equal to 960 plus H2. So that is I'm going to put a negative sign here. We're getting a negative sign here, negative sign here. So H3 is equal to 3,040 kilojoules per kilogram. My entropy will be different, but we don't have to worry about calculating entropy. So our H here, I'm going to write down a new H. H3 is equal to 3040 kilojoules per kilogram. Okay, so now I'm going to go back to my efficiency calculation. Write down work turbine is actually 960. Work pump is same as before, 100. And heat energy supplied by system is again 3,000. So this is 860 or 3,000 is 28.7%.